Hi, welcome to SQL Basics Lesson 2. Today we'll be talking about some SQL operators. In the introductory class, we looked at the basic SQL syntax where we had the select, from, where and order by conditions. And in the where clause, we looked at how it selects a subset of the data. Now the where condition has a column name, operator and a value. And if you have multiple such conditions, then they are separated by words like and or. Now all these operators, equal, not equal, between, like, etc., all of these are actually called as comparison operators. And in the previous lesson we looked at this first set of operators. So what's next? We're going to separate out the operators into different categories in the where and select statements. First we have the comparison operators like greater than, less than. We'll be looking at some of these additional things in the comparison operators. We have the logical operators like and, or, etc. And then we have the arithmetic operators, which pretty much we know since our school days about plus, minus, division, etc. For comparison and logical operators, we have looked at some information in the previous lesson, but we'll be looking at further details, and we'll be looking at arithmetic operators for the first time. Now in the comparison operators, let's look at the where condition. We have a column name, comparison operator and value. This is the general syntax for it. The column name, comparison operator, value is what we generally call as a condition, and that's the terminology we'll be using throughout the rest of this class and elsewhere. Now the comparison operators we'll be looking at in this lesson today are between and, which will help us select rows where values fall within an inclusive range, like, where we are going to search for a pattern and select the rows based on that, and in, where you can specify multiple values for a column and the query selects the data. So let's run some examples and see how to use these comparison operators. Okay, here we are in SQL Server Management Studio. And I have actually selected from the table main contact. This is the same table that we used in the introductory class, but I've added a few additional columns, age, trip expense, etc., just so that we can work with the comparison and other operators. Now the first operator that we are going to look at is between and. Let's look at that. I'm going to put that in comment. So let's say select first name, last name, age, birth date from main contact. Now where, let's say birth date between a specified range. So let's pick a couple of days. 01, remember dates must be in quotes, so 06 1980 and let's say 03 25 1985. So we chose a range of values and we are saying we want anybody whose birth date is between 1/6/1980 and 3/25/1985. So let's see what this selects. As you can see, the selection included people with a birth date of 1/6/1980 and also 3/25/1985. So this is an inclusive range actually. Now the same query actually can be written a different way, which we already saw previously. So we can say birth date is greater than or equal to and birth date is less than or equal to. If you notice, this query actually selected 6 rows of data. Now let's execute this and see. We got the same 6 rows of data. So actually, in essence, these two queries mean the same. Now let's also look at another one. Well, let's say age between 10 and 30. So as you can see, people who are aged 30 are also included in this selection criteria. Okay, so this is how the between and will work for us. Now let's open up another query and let's look at what the in operator. Let's say select first name, last name, birth date, age, where let's say first name in Mary, Satya. So we can actually include several names actually. So you can, for the same column, you can include as many values as you need. We can say Miriam. As you can see, all the three people, Miriam, Mary and Satya, have been selected here. So instead of saying first name equals Mary or first name equals Satya or first name equals Miriam, we are including all of them and saying, hey, these are all the values that I want to select from the table. So this is how the in works, and let's try the same with the age. So you can say age in 10, 13, 30. Remember, Mary, Satya, Miriam, all these are actually characters, so you have to include them in quotes, whereas age, etc. are all numeric values, so you don't need to include them in quotes. When you execute, you see people aged 13 and 30 have been selected. There's nobody who's aged 10, so that's excluded from the result set. Okay, so this is how the in operator works. Now let's go to the last operator, the comparison operator, and that is the like operator. Once again, let me just paste the previous query and let's start here. First name like. Here I'm saying I want the person's names to start with S. And then the percent implies S can be followed by any number of characters actually. So it could be 1, 2, 3, it could be any number of characters, but the first letter of the first name should be an S. So let's execute this query, and as you notice, the first names are Steve, Subbu, Sue and Satya have all been selected. Now let's run the same query slightly differently. There are different versions to this. If I want to say S must exist anywhere in the name, preceded or followed by any character. So S can have any number of characters before it and after it, but S must exist in the first name. So let's see who gets selected here. Remember, if you have multiple queries, to execute one of them, you just highlight it and hit the execute button. So now you see Justin has been selected additionally because S exists somewhere in the first name. It's the third letter. So this is how you would select any person's name with S in the first name actually. Now another different version is if I want to say, okay, I don't know the first character in the first name, whereas my second character is an A followed by whatever characters are available. For the first character, if it is just one character, you can actually provide a substitute for it and that's the wildcard, which is underscore. So this is how you're going to use underscore wildcard to substitute for just one character. Here the position and just one character substitution, for that you will be using the underscore, and then you are saying, okay, my second character should be A, and then it should be followed by a percent sign. It can be followed by any character. So let's execute this and see. I'm going to scroll a little bit so you guys can see the results. Now here, as you can see, Mary, Parvati and Satya. All these three people have A as the second character, but the first character can be anything. So that's why we used an underscore. And then A is followed by 2 characters in Mary. For Parvati it is 4 characters, and for Satya it's again 3 characters. So the percent is a substitute for n number of characters. Now let's say if I want an E, and I use 2 underscores for 2 characters. So the first 2 characters can be any values, but the third letter must be an E followed by any other character. If I execute, you can see Steve, Joe, Sue and Preetham. All of them have E as the third character. So the first 2 substitutes, for those we use the 2 underscores, and then E is followed by 2 characters for Steve, none for Joe. So in essence, the percent means if there is nothing after E, even those first names will be selected. And then we have Preetham. Now if we use, what happens if we just remove the percent and say, okay, first 2 letters can be any values, and then the last letter is an E. If you execute this, only Joe and Sue have been selected. So these are different ways of combining the wildcards, underscore, percent, etc. And then you can select all the names that you want to, or all the rows that you need to look at. Now let's say you have people whose first names start with A, B, S, whatever, a range of values, and then you don't know what other characters they may have. So in that case, what would you do? Let's try that and see. First character is A, B, S, M, let's say, followed by other characters. Instead of typing all of these like this or like that, etc., what we can do is include them in square brackets. A, B, S, let's try this and see. As you notice, anybody whose first name starts with A or B or S, actually there's nobody whose first name starts with B. So let's include M, because I know we have some people whose first name starts with M. There you go, Miriam and Mary have been selected. So you can include several people this way in the same query by using these square brackets and then followed by a percent sign. Now if the first letters are in an order, let's say A, B, C for example, or A, B, C, D for example, what do? We don't need to say A, B, C, D, E, F, whatever. All we need to do is use a hyphen, A through E for example, if you want names starting from A through E. C, D, E. Only one name has shown up. A through E, we only have one person, Anita. Let's try the last name and see if we can come up with more better results. Now you can see last name is Abraham Chintam. Let's order the by last name so that we can really see what the query is actually selecting. So here last name is Abraham, Baker, Banker and Chintam. So A through C is actually what has been selected. D and E, we don't have any last names with D, starting with D and E. So it has selected about 4 rows of data. So this is how we looked at the comparison operators like, in, and between and. So let's look at the next set of operators, which are the logical operators. The logical operators that we have in SQL are AND, OR and NOT. In our earlier lesson, we actually looked at how to use AND or OR, and then now we are also going to look at additionally the NOT operator. Now just to help us understand how the AND operator logic works, I'm going to go through a few examples here. Basically the SQL has select, from and where, and to use the AND you need more than one condition at least. So it must have at least 2 conditions minimum for the AND to be utilized, and all the conditions must hold true for a particular row from the table to be selected. Now let's look at it a little bit deeper. Now let's say condition 1 holds true for a particular row, but condition 2 is true, then that row will be selected. Let's say condition 1 is true, whereas condition 2 is false, then you don't select that row, because as we said, all conditions must hold true. If condition 1 is false and condition 2 is true, then too we reject the row. Lastly, if both conditions are false, again we reject the row. We don't select that information. I mean, this is how the query works. So only in one case where both conditions are true, the row is selected. In all the other cases, the rows are rejected. That's how the AND operator works. Now let's look at the OR operator logic. Here, when we have 2 conditions, at least one of the conditions must be true. So let's look at condition 1 is true, condition 2 is true, so we select the row. Now condition 1 is true, condition 2 is false, then too we select the row. Here, because condition 1 is true, at least one condition is true, so that's why we are going to select the row. Same case with condition 1 false, condition 2 as true. Now if both are false, that's when we actually reject the row selection, and our result set won't include a particular row if both the conditions are false. So that's how the OR operator works. In 3 cases, in all the first 3 cases, we select the rows, and in the last case, of course, we reject the row. Now let's look at the NOT operator logic. This is something I've just introduced in this class. This is very simple. If the condition is false, only then that row will be selected. Okay, so if the condition is true, then you reject the row. If it is false, then you select the row. That's how it works. So let's run some queries and see how the rows are going to be selected from our table. So here we are back to running our queries. I have selected all the data from main contact and ordered them by last name and first name, because our queries, some of them will be based on the last and first names. So these are now ordered. Let's write a query, first name, last name, birth date and age, So here we are going to use the AND operator. So let's say last name equals Rao and first name like P. So this is what I'm going to use. So we have two conditions here. Last name must be Rao and first name must start with the letter P followed by any other characters. So what the system will do when we execute this is, it will go through every row in the table and it will say, hey, is the first condition true? Okay. Then is the second condition true? If so, then that row of data will be selected. If not, the row will be not selected. So that's how the AND operator works. Let's see, we have two people here with the last name Rao and only one of them whose first name starts with a P. So that's the row we expect the system to select for us. So let's execute this. And if you notice, only one row of data have been selected. So condition 1 and condition 2 are both true only for this particular row. Now let's look at a slightly different version of this. Another query actually. Let's say birth date is less than or equal to 01/1980 and first name like S. Just to show you that we can also use this with birth dates or any other information actually. First name equals Steve. I'm assuming Steve was born on 1/6/1980. Let's see. So Steve Wagner is the only person who has been selected and his birth date is actually 1977/1/19. So which is actually this condition of birth date being less than or equal to 1/6/1980 holds true. And the first name is Steve, so that's why this row got selected. Let's look at the OR operator now. Or first name like W, or let's say even S, because we know there are two people with the last name Rao and their first names that don't begin with S. So let's see what the query will do. As you notice, Priya Rao and Satya Rao have been selected because their last names are Rao. But their first names don't start with an S necessarily, right? Only Satya starts, but Priya's first name starts with a P, but even then that row has been selected. Now let's come to the other rows, Steve, Subbu and Sue. Those rows got selected because the first name starts with an S, but definitely their last name is not Rao. So one condition was holding true. That's why in all these cases the rows have been selected. Okay. So if you want to look at another query, let's use age. Age greater than or equal to 13 and gender equals female. Do we have any rows like this? Let's check. There you go. We do have people who are aged greater than or equal to 13. Now let's say equal 13. Do we get anybody here? Yeah, there are two people who are aged 13, Miriam and Anita, and both of them are females. So that's how the rows got selected. Now let's look at the NOT operator lastly. Age equals 30 and not gender equals female. So firstly, let's look at those who are aged 30, okay? Okay. Let's look at the ages of people here. 33. Let's select 33 actually. So we have 2 males and 1 female. So let's see who gets selected when we say and not gender equals female. So basically that means if gender is female, we are not going to select that row. So the males got selected here. William and Subbu were both males. They got selected. So that means the not gender equals F means firstly it will check if gender is female, then that row is rejected. If gender is not female, then the row is selected. Okay, so that's how the not operator works. Can also use another example. Not first name equals Priya, for example. So if the first name is Priya, then we reject that row. If not, we will be selecting that row. Let's see. So everyone except Priya have been selected. We have actually 15 rows of data, but only 14 rows are showing up here. That's because we eliminated Priya from this list. Okay, so this is how the not operator works. Let's look at some arithmetic operators now. Since our school days, we have been taught about division, multiplication, addition and all those arithmetic operators. We'll just be using those in our queries actually, and they operate pretty much the same way as we learned in school days. In case we use more than one operator in the select wherever they are needed, there is a precedence and division comes first, followed by modulo multiplication, and then addition and subtraction. Actually, for further details, we can always go back to the BODMAS rules in mathematics, and that will help us understand in which order they will be executed. Now let's look at some samples. Here we notice that the arithmetic operator value for a column are actually being utilized in a select. So it's not necessarily used only in the where condition, but also in the select statement. Another way is where we can use these arithmetic operator and comparison operator and value in a where condition. So we notice that we can use a mixture of these operators, and they can be in the select or the where condition. So let's try out some examples and see how things work out. So here we are in the queries again. I actually chose the last name, first name, trip 1, expense and age from the main contact table, and here we see the result set actually. So let's actually look at each of the operators one after the other so to get a clear picture. Let's try age, and let's say we want to figure out how old people will be 2 years hence. Addition is our operator. So I'm going to execute. I actually retained the existing age so we can compare and see whether the system is actually performing the arithmetic operation correctly. As you can see, Schroeder, who's aged 33, 2 years hence he'll be 35, and so the system actually added 2 years to the age of every single person here. Now the same way we can do the subtraction. How old were we 2 years ago? So we will be using a minus, and let's change this to subtraction. So when we execute this, we see it has reduced the age by 2 years in every single case. So this is how these simple arithmetic operators can be utilized. Now let's go to the next operator, which is actually we'll be doing the multiplication. So I'm going to use age, trip 1 expense, and trip 1 expense. Let's say 2 years from now we are going to go on a trip again, and we know that the cost is approximately twice of what we paid right now. Let's look at what results will come up. Multiplication. So as you can see, it has made it twice the trip expense for each person here. So we'll have an idea how much each person will have to pay. Let's say here we'll also include the arithmetic operator in the where condition and see how it works out. So let's copy this. Just let's retain this one actually for our comparison purposes, where we'll say trip 1 expense star 2 is less than 10,000, for example. So we are saying when we increment the expense by 2 times, or actually we are looking at twice the expense, we want to figure out how many people will pay less than 10,000 if we go on a trip or another time. So let's execute this. So there are about 6 people who will pay less than 10,000 2 years from now when they go on a trip, where we are assuming the expense will be twice of what it was previously. So here, as you can see, we used an arithmetic operator and a comparison operator actually. So they are used one in combination with the other, and that too in the where condition is where we saw. Now let's look at another example. Say where is less than or equal to 15. So it doesn't mean that only the same column has to be used in the select and where. So in the select we are saying give me twice the trip expense, and then who will be aged 15 by that time is what we are going to look at. So when we execute, age plus 2 actually, because here we go, we have about 3 people who are currently aged 13. 2 years from now they'll be 15 years old, and their trip expenses are 14,690, 5,980 and 8,000 actually. So this is how we can use a combination of the operators, and we came to multiplication. Let's look at division right now. As we notice, there are 3 people who are aged 13 and their trip expense are 7,345, 2,990 and 4,000. Let's say people felt, okay, these people are too young to pay this kind of money, so let's divide up amongst the rest of the people in the group. So we have about 15 contacts, and if we remove 3 of them, then there will be 12 contacts. So let's select trip expense divided by 12. So how much will be the expense per person for these 3 people if we divide them by the 12 people who are remaining and who are not aged 13? What will their additional expense be? So where age equals 13. So when we execute this, we notice that for Miriam Stanford, the remaining 12 people would have to pay about $612 each. For Anita, about $250 per person additional expense is what is necessary for them to pay. And for Michael John, the rest of the 12 people need to pay about $334. So that's how we use the division here. These are all very, very simple calculations that we have seen in math, and that's what I have shown you here. Now actually let's also look at the precedence of operators a little bit before we wrap up things. I know this is not division, but let's say operator precedence. Now let's say people who are going to be aged 15 2 years from now, let's say they have a discount of 50 rupees. So we would be saying the expense is twice 2 years from now, and if they are aged 15 by that time, then they'll get a discount of 50. So this is where we are using actually a mixture of operators, arithmetic operators I mean, multiplication and subtraction. Let's execute this. We notice here that actually let's also include twice the amount and see how it comes out. So twice the amount is, for Miriam it is 14,690. So you subtracted 50 rupees from from that, and we got 14,640. Similarly, it works the other way for Anita and John. So the trip expense has been made twice, 2 times, and then 50 was subtracted. Now let's see, if we change this a little bit and say minus 50 and multiply that by 2. Is this the same? Now here, this is where we'll actually see the precedence of the operator multiplication. So let's execute this and see. Now if we notice, actually the twice the expense is actually 14,690 for Miriam. But from that we are not subtracting actually 50. So what did the query do? It actually took trip expense minus 50 times 2, which means trip expense minus 100 actually. So the multiplication was done first, which means 50 times 2 is 100. So from the trip expense, for each person 100 is subtracted. So if you notice here, 7,345 minus 100 is 7,245. So that's how the operator precedence works. And I know that you are all aware of this, but I just wanted to show it to you in a query, so you'll have a better understanding about the BOD-MAS rules and why we need to know about it and how it works actually. So I hope you enjoyed the class and learned a little bit about the operators today. So we'll meet again in another class and learn a little bit more about SQL. Thank you for enjoying the class.